In this video, we will be covering an important topic, that is electric dipole moment, and electric field intensity at axial point of electric dipole. So the first thing that we'll be starting is electric dipole. See, dipole is made up of two words, di and pole. You know what is di mean? Di means two. Pole can be anything which are opposite. For example, geographic North Pole, geographic South Pole, magnetic North Pole, magnetic South Pole. These are just poles. There can be opposite charges also. For example, one can be a 5 coulomb charge and another charge can be of minus 5 coulomb. So these are the opposite charges. So electric dipole is when two equal and opposite charges are separated by some small distance. That is known as electric dipole. That system is known as electric dipole. So electric dipole is equal. I will write down here, equal and opposite charges separated by small distance. This is called electric dipole. This is a definition. Now I will show you a diagram of electric dipole. Suppose it's a line. Let there be a line, and on two opposite ends of this line there are two charges. One is Q and the other is minus Q. The distance between these two charges, for derivation purpose, we take it as 2L. But in some books you might find 2A written over there. So you can use 2A also, or 2L also. Right? This is the basic diagram of electric dipole where two charges are separated by some small distance. 2A is a small distance. Fine. The next term that is associated with electric dipole is electric dipole moment. Electric dipole moment. Electric dipole moment is nothing. It is just the product of either charge of dipole and its dipole length. So it is defined as product of either charge and dipole length. It is denoted by a letter P, and its formula is given by Q multiplied by 2A. P is the symbol given to the electric dipole moment, and its formula is Q into 2A. It is a vector quantity and its SI unit is Q into 2A. So Q is coulomb and A is length, so that would be meter. Coulomb meter is the SI unit of electric dipole. Now we will be calculating electric field intensity at axial point of electric dipole. So here is the electric dipole, minus Q plus Q, separated by distance 2A. This A point is on its axis, or it is an axial point, if I say, on which electric field intensity is to be calculated due to this dipole. So the first thing which we will do is we will give distance to this point from the center of dipole. Let this distance be equal to R. Now see what would be the distance from plus Q to this, from plus Q to A point. The would be distance would be R minus A. And similarly, if we see the distance from minus Q to A, this would be equal to R plus A. Now at point A, that where we have to find electric field intensity, there are two charges which will be contributing towards the electric field at that point. The one charge is plus Q and another charge is minus Q. So the first thing that we are going to do is give direction to the electric field. Due to plus Q, electric field would be away at A, and due to minus charge, it would be towards minus Q. These are the properties of charges. That electric field of plus charge is outwards and minus charge is inwards. So give name to these electric field. Let one be E1 and this one be E2. Now, in the previous video, we learned what is electric field due to a point charge. The formula was kq by r square. So similarly, we are going to find E1 and E2 first. So let's find E1. E1 is equal to kq by r square. R is distance from plus q. E1 is due to plus q. Distance from plus q to A is r minus A. So it would be r minus A whole square. Similarly, E2 would be equal to k kq and distance is r plus a whole square. So the first step in this derivation is to give directions to electric field intensity, and then we have to find electric field intensity E1 and E2 by using the formula. Now you have to see the direction. As you can see, E1 and E2 are in opposite direction. So the net electric field at the point A would be equal to E1 minus E2, right? Why? Because both are in opposite direction. So vector are in opposite direction. So net would be by subtracting these two electric field intensities. So now we will be putting the values in this. E is equal to E1 minus E2. As you can see, there are some common things in E1 and E2, that is KQ. So while subtracting, we can take common KQ. What I'm left with? I'm left with 1 minus r minus a whole square minus 1 plus r plus a whole square. Now you have to take LCM and solve. If you take LCM, answer would be a is kq outside the bracket. If you take LCM and use the formula of a plus b whole square and a minus b whole square, the term that you get inside the bracket is 4 4 r a. This is the term which you will get after solving this. R plus a whole square will go here, r minus a square over here. When you open these two, r square and a square will get cut. You will be left with 2ra and 2ra. So 2ra becomes 4ra. Divided by LCM would be r minus a and r plus a whole square. We will be left with r minus a r plus a. This is the LCM. Okay. Now a minus b and a plus b is a square minus b square. So what you can write is, you can write kq4ra as the numerator, and it becomes r square a square whole square. Okay. In next step, see, dipole length is small, so a would be much more smaller and a square would be much more smaller. So you can neglect a square. You will left with r4, and r4 will cut. You will get rq. So you will be left with k q 4 a divided by r cube, because r square and square become r4. There's one r in numerator and it will cut down the denominator and you are left with r cube. This is done by neglecting a square. Now see, the last topic was dipole moment, that was q into 2l. So here you can see that there is q, 4 can be written as 2, so 2 into 2, q into 2 can be written as p. So this formula can be written as 2 k p by r cube. This will be formula of electric field intensity at axial point of electric dipole. I'm just going to repeat the steps. You have to find E1, E2, see the direction, put the value of E1, E2 in the net electric field intensity, and then you have to just solve it mathematically. The last answer would be 2 kp by r cube.